Hello. In this video, I'm going to explain problem 21 from the 2015 F equals MA contest. In this problem, we are told that an object is launched vertically upward from the ground with a speed of 50 meters per second, and then it will come up, go back down, and then it'll bounce up again, and we're told that the coefficient of restitution is 0.9, meaning that the speed after the bounce is 90% of the previous downward speed, so it'll be 45 meters per second. Then it'll go up. It won't quite go like this. I'm just doing this so that there's more space, and it'll hit the ground again, and then it will come up. Again, all of this is actually straight up, but it will come up at some new speed, so it'll be 40.5 meters per second, and it'll come down again. And basically, it'll become a smaller and smaller bounce. I guess you could plot this as, height versus time, although of course this is a very bad drawing. And so we're told to find the total amount of time between when the ball is launched and when it finally comes to rest. And we're told that the bounce is instantaneous. So we can tell that since the velocity at the launch is multiplied by 0.9 each time, there are actually going to be an infinite number of bounces, and so it's actually going to be an infinite series. But you can also tell that it's most likely going to be an infinite geometric series since the velocity is multiplied by a constant factor each time. So the first question is, how long for a single bounce? This is very messy. This is a fairly standard projectile motion problem. Let's say we have a speed v. Then we know that the particle is going to go up and come back down. And we know that the acceleration due to gravity is g at all points. And so here is what we know. We know that the displacement after a certain amount of time. There are many ways. We can use many of the different constant acceleration kinematics equations to solve this. But what we can do is we can find the displacement at a particular time. And so the distance at a particular time will be equal to the initial position, which is actually 0, plus the initial velocity times the time, and then plus 1/2 at squared, where a is the acceleration. The acceleration is actually negative g squared, so I'm going to define this as the positive direction. And then we want this to be 0. And so what we get is vt minus 1/2 gt squared equals 0. And so we are told, and so we can see that 1/2 t times 2v minus g equals 0. 2v minus gt. And so obviously we want the time that's not 0. So we know that 2v minus gt is 0, and so t is equal to 2v over g. There are many ways to get this result, but this is one of them. And so now, we know that what are the velocities going to look like? Well, we know that by the conservation of energy, or by the kinematics equations, the velocity when it lands is going to be the same as the velocity at which it was launched for a single bounce. And thus we know that the velocities are going to look like v naught, which was 50 meters per second, and we're going to have r v naught, or c sub r, that's 45 meters per second. Then we're going to have cr squared, because it'll get multiplied by c naught again, and then cr cubed, and da da da. Right? And so thus, and remember that the time, so we'll say that v sub I is equal to cr to the power I times v naught, and ti is equal to 2 times vi over g. This is the time for the ith bounce, starting at 0. And so that will equal 2v naught over g times cr to the power I, and thus we see that the total time t is the summation from I equals 0 to infinity of Ti. And so 2v naught over g is the same for the entire motion. And then we get the summation from I to equals 0 to infinity of Cr to the I. This is a well-known geometric series, and it's one that you should commit to heart. So if you have x, or 1 plus x squared plus, 1 plus x squared plus x cubed, and so on. That's 1 over 1 minus x. You can see that from the formula for a geometric series. So its first term is 1, and then 1 minus the common ratio is 1 minus x. And so this is something that you should know by heart. And so we'll use that here. So we have t equals 2v naught over g times 1 over 1 minus CR, where CR is the coefficient of restitution. And now we can just compute everything. So we are told that v naught is 15 meters per second. Coefficient of restitution is 0.9, so it'll be 2 times 50. So all in SI units, 2 times 50. G, the general convention for F equals ma, is G equals 10 meters per second squared. And then 1 minus 0.9 is 0.1, and 1 over 0.1 is 10. And so we end up getting t equals 100 seconds. Since we did this all in SI units. And thus we see that the answer is 100 seconds. All right. That's all there is to this problem. All right. I hope that was helpful, and thank you for watching.